Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about FIR ideal low pass filter. So given problem is design an ideal low pass filter with a frequency response of ht of e power j omega will be equal to for the range of frequency minus pi by 2 to plus pi by 2, and that will be equal to 0 for the range of frequency plus pi by 2 to plus pi, similarly minus pi by 2 to minus pi. So because it is mentioned as a modulus of omega. So they asked to find the value of h of n for the given value filter order is n equal to 11. Also they asked to find h of z. So first we need to find the h of e power j omega. First we can plot the frequency response. Look at this. So h of e power j omega will be equal to for the range of frequency minus pi by 2 to plus pi by 2. Look at this graph. So minus pi by 2 to plus pi by 2, this value will be equal to 1. So first I plot this. Second, look at this. This will be 0 for the range of frequency plus pi by 2 to plus omega. Similarly minus pi by 2 to minus pi. Look at this. So plus pi by 2 to plus pi, this will be 0. And then similarly minus pi by 2 to minus pi, this is also 0. So we need to integrate only for the range from minus pi by 2 to plus pi by 2. That is also h of e power j omega will be equal to 1.0. That is 1. So I am taking the formula for this h of n equal to 1 by 2 pi integral of minus pi by 2 plus pi h of e power j omega into e power j omega n into t omega. So what we know that we know the range and then h of e power j omega. So just substitute it. So 1 by 2 pi into integral of minus pi by 2 plus pi by 2, because remaining ranges that value will be 0. And h of e power j omega equal to 1. So 1 into anything will be that anything value and value comes. So 1 into e power j omega n into d omega, that is equal to e power j omega n into d omega. Now we have to integrate this and we need to substitute this value as upper limit and lower limit. So what we get? So if you substitute this e power j omega n, so integrate it, we get as e power j omega n. Also again we need to differentiate this. So if you differentiate this e power j omega n with respect to d omega, we get as j n. So that's why I am putting this as a j1 in a denominator. So 1 by 2 pi, again jn is taken as a common, and then integrated value is e power j omega n. We need to substitute the upper limit and lower limit as a plus pi by 2 and minus pi by 2. So now I am taking this as combination of 1 divided by pi n into 2j, because if I take an e power j theta minus e power minus j theta divided by 2j, it gives an sign value. So that's why I am taking this as a rewriting this. So look at this pi and this n will be taken outside, and then remaining I have this 2j, because I am going to combine this value with this 2j. So here if we are substituting these two values, upper limit and lower limit for this omega, so already it have an e power j omega n. So instead of omega we need to substitute it a pi by 2. We get e power j pi n divided by 2. Similarly for a lower limit, minus of this minus pi by 2. So minus e power minus j pi n divided by 2. So now we combine these two values, that is e power j n pi by 2 minus e power minus j n pi by 2 divided by 2j, it gives an sin n pi by 2. Look at this. I am taking this as a sin n pi by 2. Remaining I have only thing is n pi. Look at this. We can put it this as n pi. So this is the integral value for this hd of n. So here we need to find it hd of n. For the n value we can substitute it. So look at this value, denominator we have an n value. So what happens if I substitute 0 for the denominator, 1 by 0 it becomes infinitive. So only for hd of 0 we cannot substitute this equation. For that we need to use the same expression before integrating, because if you substitute here this will be becomes infinitive. We have two methods. One, we can use this as an limit method, and another one is we can use this before integrating expressions. Look at this. Look at this. So this first method we need to find this is an limit method, and this is an before integrating method. So actual value is, first we need to truncate h of n to 11 samples because capital N given as 11 samples. So we read it as h of n equal to the final result sin n pi by 2 divided by n pi for the value of modulus of n less than equal to pi. That means minus pi to plus pi, it comes 11 samples. And that will be 0 for otherwise because we are going to truncate for an n value. So capital N equal to 11. Now we can find this h of 0, 1, 2, 3. So h of 0 we need to find means, so find put n equal to 0 in the equation. So once if you substitute this 0, it becomes infinitive. That's why I am using this limit method. So h of 0 will be founded using this limit method. So limit n tends to 0 and then sin n pi by 2 divided by n pi. So once if you substitute it, we get a 1 by 2 into limit n tends to 0 and then sin n pi by 2 divided by n pi by 2. So once if you substitute this, so this is the formula for that. So sin theta by theta, that will be equal to 1. So I am using this formula, I am getting the result as 1 by 2. Or I can use the alternate methods. So here we need to know the limit method. Even if you don't know limit method, we can use this alternate methods. So h of 0 equal to h of 0. So I am using this before integrating expressions. Look at this. So h of 0 equal to 1 by 2 pi integral of minus pi by 2 to plus pi into d omega, because e power j omega will be equal to 1. So if you integrate, what we get? So d omega integrated, we get omega only. So 1 by 2 pi, this is an integral expression, into integration will be omega only. So I am substitute omega with the upper limit and lower limit. So 1 by 2 pi we take a common. So omega if you substitute it, pi by 2, and then minus again if you substitute it, minus pi by 2. So minus of minus pi by 2 will be plus pi by 2. So what happens? So 2 pi by 2, that will be pi by 2. So we can substitute here. Already we have this 2 pi. Again if you combine it, so pi divided by 2 pi. So pi will be cancelled. You get 1 by 2. So this is the final answer. So h of 0 will be equal to 1 by 2. Now we can substitute h of 1. So very simple. So just substitute h of 1 in the derived formula. So look at this, sin n pi by 2 divided by n pi. So if you substitute h of n will be equal to h of minus n, that will be equal to sin n pi by 2 by n pi. So n equal to 1. So we get a sin pi by 2 by pi, that will be equal to 1 by pi, that is equal to 0.3183. Thank you.